Dear students, in this video I will explain Kohlrausch law of independent migration of ions. The equivalent conductance at infinite dilution lambda infinity. Equivalent conductance at infinite dilution is denoted by lambda. This is big lambda. Infinity of an electrolyte is equal to the algebraic sum of equivalent conductances or mobilities of the cation lambda naught plus and anion lambda naught minus of the electrolyte at infinite dilution. So mathematically Kohlrausch law is written as lambda infinity is equal to lambda naught plus lambda naught minus. So the algebraic sum of infinite dilution conductivity of ions at infinite dilution is equal to conductivity of equivalent conductance of electrolyte at infinite dilution, where lambda plus is equal to equivalent conductance of cation at infinite dilution. Lambda minus lambda naught minus is equal to equivalent conductance of anion at infinite dilution. Lambda infinity is equal to equivalent conductance of an electrolyte at infinite dilution. The equivalent conductance of an ion is directly proportional to the mobility of ion. Lambda naught plus is directly proportional to mobility of cation is denoted by U naught plus. So lambda naught plus is equal to K into U naught plus. Here K is proportional constant. Similarly, lambda naught minus is also directly proportional to U naught minus. So lambda naught minus is equal to K into U naught minus. So lambda naught is equal to K into mu naught plus U naught minus, where U naught plus and U naught minus are mobilities of cation and anion. K is equal to proportional constant. That value is equal to 96,500 coulombs. So it is also called Faraday. 1 Faraday equal to 96,500 coulombs. Now let me explain the relation between standard Gibbs energy delta G naught or delta GF naught and standard electrode potential E naught cell. So the relation is delta G naught equal to minus N into F into E naught cell, where delta G naught equal to Gibbs free energy, N is equal to number of electrons or charge on ion, F is equal to Faraday constant, that is 96,500 coulombs, and E naught is equal to standard electrode potential. Let me explain the problem related to that Gibbs energy. The standard EMF of Daniell cell is 1.1 volts. Then calculate the standard Gibbs energy for the Daniell cell. So here standard electrode potential is given, so E naught is equal to 1.1 volts. N is equal to 2 because this is the relation of Daniell cell, reaction of cell reaction Zn plus Cu2 plus gives rise to Zn2 plus Cu. So charge on ion is 2 plus, so therefore N is equal to 2. And F is equal to 96,500 coulombs. We need to find delta G naught value, standard Gibbs free energy. So therefore according to relation, delta G naught equal to minus N F into E naught. So that is equal to N value 2. So minus 2 into F value Faraday constant 96,500 into E naught standard electrode potential 1.1. If you multiply these three, we get minus 212,300 joules per mole. If you convert this joule per mole into kilojoules per mole, we get minus 212.3 kilojoules per mole. And again the another important relation, the relation between standard electrode potential and equilibrium constant. E naught is equal to 0.059 by N into log Kc. This is the relation between standard electrode potential. Standard electrode potential is denoted by E naught. So E naught cell is equal to 0.059 by N into log Kc, where E naught cell is equal to standard electrode potential, N is equal to charge on ion, Kc is equal to equilibrium constant. Let me explain the problem related to that relation. So here calculate lambda m naught for CaCl2 and MgSO4. Given lambda naught Ca2 plus is equal to 119, lambda naught Cl minus equal to 76.3, lambda naught Mg2 plus equal to 106. Standard equivalent conductions are given, and lambda naught SO42 minus equal to 160. We know for Kohlrausch law, lambda naught m CaCl2. This is molar conductivity at infinite dilution for calcium chloride is equal to lambda naught Ca2 plus 2 into lambda naught Cl minus. Because CaCl2 has ions Ca2 plus and Cl minus ions, so therefore Ca2 plus 2 Cl minus. That's why we get 2 here. Lambda m naught CaCl2 is equal to lambda naught Ca2 plus lambda naught Cl minus 2 into lambda naught Cl minus. Lambda naught Ca2 plus cations equivalent conductance at infinite dilution is given, that is 119, plus 2 into chloride ions infinite dilution conductivity is given, that is 76.3. So therefore 119 plus 2 into 76.3 we get 152.6. If you add these two we get 271.6 Siemens centimeter square mole per minus 1. And we need to calculate this value also. This is lambda m naught MgSO4. That means magnesium sulfate molar conductivity at infinite dilution. According to Kohlrausch law, any infinite dilution of any electrolyte is equal to sum of the ions. So lambda naught Mg2 plus ions plus lambda naught SO42 minus ions, because MgSO4 solution contains Mg2 plus ions and SO42 minus ions. Here Mg2 plus ions conductivity is 106 is given in the problem, and SO42 minus ions conductivity is also given, that is 160. If you add these two we get 266 Siemens centimeter square mole power minus 1. Let me explain another problem relation to Kc and equilibrium constant. Here calculate the equilibrium constant of the reaction Cu plus 2Ag plus gives rise to Cu2 plus 2Ag. Standard electrode potential is given, that is 0.46 volts. So we know that the relation between standard electrode potential and equilibrium constant E0 cell is equal to 0.059 by N into log Kc. Here 0.059 by N into log Kc. E0 cell is given, so 0.46 E0 value is equal to 0.059 by 2 into log Kc. So if you send 2 and this fraction to this side, we get 0.46 into 2 divided by 0.059 is equal to log Kc. If you calculate this fraction, we get 15.6. Therefore, log Kc equal to 15.6. Next, here Kc equal to anti-log of 15.6. If you calculate from logarithm tables, we get 3.981 into 10 power 15. That is the Kc value.